Hi everyone, this is Kiran Earalli. I head Snowflake COE at LTI Mindtree and also lead PolarSled product development team. Today we are going to talk about Snowpark and how do we migrate to Snowpark and how do you do MLOps on or the AI engineering on Snowpark. So before that, let me introduce you to LTI Mindtree. So LTI Mindtree is a global consulting company with operations around 33 countries. We have around 90K professionals working, and we have Snowflake as a separate SBU with 850 professionals working. Out of that, we have 250 plus Snowpro core certified professionals. And also, I'm happy to say that we have 25 plus advanced architect certified Snowflake professionals. Which is highest among the any GSIs across the globe. And we have implemented around 60 plus Snowflake implementations as of now. And the two marquee products accelerators we have are FOSFOR and PolarSled, which you are going to see in action today. So let's get into the today's session. So today's session has two parts to it. So one is Spark to Snowpark migration using PolarSled, and then you have AI engineering on Snowflake Data Cloud using Refract. So let's get into the first part now. So before we get there, let me show you like what kind of Spark workloads are people implement, right? If you see any Spark data lake or data lake house kind of implementations, you see three kinds of workloads here, which is the data ingestion, data engineering, and the data science. So data ingestion, usually it might be an ETL or a Spark metadata driven frameworks written, which can get the data from outside to say HDFS or Delta Lake tables or any of the Hadoop systems, right? That's about data ingestion, but where you see that there is a low automation or no automation possible with PolarSled for data ingestion jobs. So we prefer to basically repoint those workloads as is to Snowflake. And then coming to the data engineering, which is a sweet spot for Snowpark kind of a migration, where this is the where you get the high automation using PolarSled. So all the data engineering jobs are the best suited for Snowpark migration. And then coming to the last workload, which is the data science workload. So in data science workload, you have two parts to it. One is the feature engineering within data science, and then the ML model training and the predictions, right? So the feature engineering part is again well suited for Snowpark migration. So that part also can be automated using PolarSled. So these are the high level three workloads any Spark jobs can fit into. So moving on, so if you see, this is a as-is architecture, a typical architecture for a data lake or a data lake, lake house kind of an architecture, where you see multiple layers here, and each layer would be most probably a different technology, and they are kind of interacting with others and having hard time to integrate everything to achieve what is actually required. But when this is migrated to Snowpark, you will see something similar to this, meaning most of it gets consolidated into Snowflake's Snowpark kind of environment here. So a lot of things can be well integrated, a unified platform rather than having multiple technologies having hard time to integrate with each other and communicate, work together, right? So this is the to be kind of an architecture. Then moving on, let me introduce you to LTI Mindtree PolarSled. So this is the accelerator. Again, it has been taken into Unix as a philosophy. So what we do here is basically it's a suite of tools. Each tool does a specific job and best at it, right? So and when they come together, they solve a bigger problem. So similar philosophy we have used for PolarSled as well. And today, we are going to see five tools here with a green tick on them. So Smart Analyzer, Dependency Analyzer, Cloud Convert, Cloud Upload, and Smart Validate. So PolarSled is basically divided into four pillars: strategize, migrate, govern, and mesh. But today's we are going to concentrate on strategize and migrate alone. govern and mesh are not for today. And if you see the bottom of the slide, there are all the systems which are supported by PolarSled, which helps to migrate all these systems to Snowflake. Now coming to our first tool, Smart Analyzer. So Smart Analyzer basically helps you to do the landscape analysis. And for today, we have taken Spark as the source here, Spark to Snowpark migration. So Spark code analysis, it helps you to analyze how complex or how simple is the current system, and are there any risk associated with automation risk associated with the current system. All that information is provided by Smart Analyzer, which we are going to see in action today. Then coming to dependency analyzer, if you take any PySpark code or Scala code, you have multiple Scala scripts or the Python scripts here, and each might be dependent on each other because there might be a common code which might be used across the scripts. This information needs to be handled carefully, because when we are migrating to Python stored procedure when in Snowpark, we need to handle carefully because we cannot have that interdependencies. So we'll have to create separate store procedures, or we have to embed that part of the functionality within the main store procedure. So that becomes really critical, which dependency analyzer handles it. Then coming to the second pillar, migrate, which does the heavy lifting of the entire migration activity. So Cloud Convert will help you to migrate your PySpark or Scala code to Snowpark compatible Python or Scala stored procedures. And from there, once you have migrated, analyzed the current landscape, migrated the code, then comes you need a tool to migrate your history data. So for that history data, you have Cloud Upload, which helps you to migrate your history data. And once you have migrated your history data, you need a tool to reconcile the data between your current system to Snowflake. That's where Smart Validate helps it. So that's about a high level view of what our LTI Mindtree PolarSled. Uh, Moving forward, so you have seen in analysis phase, we use Smart Analyzer, Dependency Analyzer, and then we have three kinds of jobs here, basically data ingestion, data engineering, and data science. So data ingestion jobs are basically, we'll have to manually repoint it to Snowflake. And data engineering and data science, the feature engineering part will get converted to Python stored procedures. And history data is used, moved to Snowflake using Cloud Upload. And finally, the reconciliation happens using Smart Validate. And from there, the governance, we have separate tools altogether. Then let's get into demo. Okay, so this is the landing page of our LTI Mindtree PolarSled. First thing is, you will have to understand, we have to create three types of connections here. So the first connection is the source connection. Today I have for source, I have taken Hive as the source. Then you need a AWS connection basically to stage our files into cloud storage area. So I have taken AWS as the connection type. And finally, the destination, which is our Snowflake. So being cognizant of time, I have created all these connections and kept it ready. So moving on to our first tool, which is our Smart Analyzer. So in our Smart Analyzer, you have two options. Either you can provide a Git repo from where the code can be analyzed, or you can give, assuming that your code is already there on your current system, you can actually browse and upload the data to PolarSled and hit analyze. It takes some time to analyze the code depending on the complexity of the code. So I have already analyzed and kept the report ready for one of the two of the repositories. So if you see here, what we have done is we have analyzed two repositories. So 7,000 plus lines of code and 125 scripts have been analyzed. And each folder in your code repository becomes a here it is shown in the complexity distribution here. So each script is analyzed. It is found out if there are any risks and how complex is that current system, current script for migration to Snowflake, right? It is categorized into simple, medium, complex categories. And once the complexity definition is defined, it also does the risk analysis, the automation risk analysis, right? So in automation risk analysis, what we do is we find out if there are any functions which where you don't have an equivalent Snowpark function, or there are functions which are actually not applicable, right? So if, for example, say RDDs are not supported in Snowpark, again you need a manual intervention there to some extent. Then you have when you are processing the data using uh, Spark, what happens is you will have to understand the data distribution, and you will have to do a partitioning, repartitioning of the data to achieve maximum performance, right? So, but those are not required in Snowflake when you move to Snowpark, because the micro partitions automatically take care. And if there are any packages, the Python packages, which are not there in Snowflake, current Snowflake environment, so those are even highlighted. Again, even the most of the time we use SQL, Spark SQL, and within SQL, if there are any Cartesian joins, right? So Cartesian joins on current system might be just a performance issue, but when it moves to Snowflake, it might be a cost issue as well. So those are highlighted, which needs your manual intervention. Again, risk analysis is not only at the summary level. What we do is we go down to each and every script and what is the risk factor associated with that, and how many occurrences of those risks are there, right? So if you see, there are RDDs, map function, flat map functions which are highlighted, and there are collace, repartitioning, or for each kind of things are all highlighted, so which needs your manual intervention to fix them and move forward. Then the entire inventory, right? So that's about the strategize here. So we have done the analysis of the current system at the code level. Now the next step is to do the analysis at the dependency, right? Between the scripts, how you want to, what is the dependency and how we want to migrate it, right? So these the two information gets fed into the conversion category, and it will be helpful. So if you see here, first thing is you have done the analysis. Now you are doing the dependency analysis. Again, I have already analyzed it and kept the report ready. So if you see here, this is how the analysis is shown. Here you have two types of scripts. One is the base script, and one is the green one is the base script, blue one is the dependent script. So what do you mean by base script is basically you mean that there is no dependency for this base script to be migrated to Snowpark. It can independently get migrated to Snowpark without any issue, right? As an individual. But when it comes to blue script, they are dependent on green scripts. There might be certain functions which are there in green script are being used in this, so they are dependent. So to migrate them, the first base script have to be migrated. To understand this information, this dependency analyzer helps you to do it, understand this, and this information gets fed into the next level. Now coming to the migrate, right, which is the actual heavy lifting of the PolarSled activity here. So let's go ahead and convert few scripts here. And after the conversion, I want to create it on Snowflake. So I'm selecting a Snowflake connection, and these are the scripts. And let me select few scripts here for demo purpose. We have created few scripts. Let me go ahead and run this. Okay, now in the meantime, these scripts are being converted. Let me show you how the conversion looks like, right? So on the left-hand side, if you see, it is a PySpark code. On the right-hand side is the PolarSled converted Python stored procedure. Now, few things, the nuances, key nuances, what we are taking care, I'll share here. If you see, there are certain import statements on the left hand side, line number 1, 2, 3, right? But in PySpark, you can import the statements at any given point of time. It is nothing like you will have to import them starting of the script, right? But at the when it comes to the Python stored procedure, all imports have to be defined before the stored procedure run statements, right? So those all are consolidated. And also, if you see, there are certain import statements like SQL expression, which is not at all there on the left hand side current system. But to handle few conditions, we'll have to import this particular import. So all such things are handled. Then coming to the schema, the way it is defined on the PySpark versus the way it is defined on the Snowpark is almost the same, but only the thing is their data type mapping has to be appropriately mapped to Snowpark data types. Then coming to the way data is being read from a particular folder, but when it comes to Snowpark, you can't read it from an external folder like an S3 or HDFS location. Rather, you would have to read it from a stage environment. So that is where we are reading it from a stage. It's automatically getting converted to a stage. And then few more nuances, like say, for example, on line number 53, you see that there is a contain statement here. How the contain statement works on a PySpark code versus the contain statement handled on the Snowpark side, right? So like this, there are multiple nuances, and you can see that there is an RDD as well, which is handled here with a map function here. But when it gets converted to RDD on the Snowpark side, a Lambda function needs to be created with an apply function. So all that is taken care automatically with PolarSled. And finally, you see that the data is getting returned to a Delta Lake table here, and the way it is returned to a Snowflake table, all the format changes automatically, and you get around 60 to 70% of automation with the PolarSled conversion here. Now coming back to our PolarSled. So if you see here, the 10 scripts have got converted. You can see even the source information versus the converted information side by side. Okay. Now we have done the analysis. We have found out the dependencies and converted the code and migrated the code to Snowflake. Now we need to migrate the data. So to migrate the data, we need a cloud upload tool, which where we are going to migrate certain data here. So let's go to Snowflake and see that there is a customer table here, and I don't see any data here. So let's upload certain data to Snowflake. So I'm selecting a cloud storage where the data has to be a file has to be staged, and then I'm selecting a file which has to be uploaded, and a Snowflake connection. And once the it is hit upload, so basically it is just not a normal just a upload utility. Rather, I would say that here you have certain nuances, like you can use internal stage, you can use external stage, and if you want to use client-side encryption, you can use client-side encryption to upload the data to Snowflake. All those things are handled, and it can upload up to 2 to 3 terabytes of data per day. So now if you see that we have uploaded 2000 records to Snowflake, let me go ahead and check it in Snowflake. So if you see here now that 2K records have been uploaded to Snowflake. Now, so what we have done is basically we have analyzed the current code, and we have found out the dependencies, and then we have migrated the current code with automation with 60 to 70% of automation to Snowflake. Then we have migrated the history data now using the cloud upload utility. Now the final phase is basically to validate your current data in Snowflake versus the source. So basically when you are extracting the data from current system and loading it into say S3 or any cloud storage, and then loading the data into Snowflake, there are chances that the data might get corrupted due to platform differences or serialization, deserialization. So you have to be very sure that all the data is uploaded properly, and there you don't have any issue, right? You have to reconcile that. So we have 3 levels of reconciliation here. Let me go ahead and validate these records. So first level of reconciliation is sanity check. So basically the count match, the count of nulls, distinct and all. Then for number values, you have min, max, average kind of check, which is the statistical checks. And finally, we have a SHA1 hash value validation, right? So what does the hash value validation mean is you actually concatenate all the columns on the source, create a hash value, and similarly on Snowflake, and you match the hash values. Even a slightest difference on source to target is caught with your hash value validation, right? So this is the final summary information which is here, and you can download the report and look at the report as well for the Smart Validate. A sample report for Smart Validate looks something similar here, which table you are trying to validate from PySpark versus Snowflake at what time and all, right? And what all actions you have validated, and each record, if it is matching at each level or not. All this information is recorded, and even if there are any mismatches, these mismatches are highlighted here. So this becomes like a tested evidence for you. So that is about smart validate here. Now coming back to our ROI on our PolarSled, right? First is basically the entire PolarSled ROI. We are able to reduce your analysis phase from months to days using our smart value analyzer and the dependency analyzer. Then we are able to do the automation to convert your current PySpark or Scala code to Snowpark code with 60 to 70% of automation. And we are able to help you reduce your efforts in data migration and data reconciliation, which is a hectic job. There you have a automated tool to help you reduce your efforts, and the governance will help you in cost optimization of the Snowflake. Then coming to today's demo, what we have seen, we have analyzed 7,000 plus lines of code using Smart Analyzer. Then we have converted 100% of the code, around 400 lines of code has been converted to Snowpark. The reason for 100% here is all the patterns within the current code was already codified. So you see this 100%, but usually we commit for around 70%, 60 to 70% of automation. Then also we have uploaded 2,000 records and reconciled those against the source, right? So all these are the demo stats for today. Then moving ahead, so what we completed Sparks to Snowpark migration using PolarSled. Now I'll hand over to my colleague Ranga, who is going to cover AI engineering on Snowflake Data Cloud using Refract.
This is Ranga. I'm the CTO at FOSFOR, the data products division of LTI Mindtree. Today we are going to talk about Refract, which is an AI engineering platform built for Snowflake Data Cloud. We will first cover the core concept around which we have built Refract, and then we will look at a quick demo covering multiple personas related to AI engineering. So to start with, if you look at the entire FOSFOR product suite that we have, there are multiple products which cover the entire data to decisions journey. But today we will primarily focus on Refract, which is basically an end-to-end AI engineering sort of platform to build, test, and deploy your ML models on Snowflake. Now, if you look at any say ML project, it typically has multiple personas who have varied needs, and also there are multiple stages in the life cycle of an project. So typically a ML project starts with a data scientist who will explore the data, conduct multiple experiments, do a lot of hyperparameter tuning, selection of models, etc. And then he comes up with the final model, which can be say sort of deployed into production. And then before you deploy the model into production, there is always a need to validate the model to make sure that it satisfies all enterprise criteria. There are no unknown risks. The quality of the model, the accuracy of the model, things like bias, explainability are properly say sort of tested. So typically you have a validation persona which actually verifies the model built by data scientists to make sure that all those things are taken care. The next step would be to deploy the model into say production, and typically you have an MLOps engineer who does this. Also, MLOps engineer is responsible for making sure of uptime, availability, and other say sort of characteristics of the model so that the model is in operation. And also typically they monitor drift so that if there is any need for retraining or any corrections to be done to the model, they can go back to the data scientist. Finally, the whole ML activity has to be governed from an end-to-end point of view. So there is always a model governance officer type of a role, which looks at the entire ML engineering lifecycle from an end-to-end perspective and makes sure that every activity is done according to the enterprise standards. So when we talk about building Refract on top of Snowflake, typically there are two main pillars or capabilities of Snowflake on which we have we have been building the product. One is definitely Snowpark, and the other one is Streamlit. So today I will showcase some of the capabilities of Refract with respect to both Snowpark and Streamlit. Now, if you look at the end-to-end logical architecture. It looks something like this. So at the bottom, you have the data cloud, Snowflake, all the data on which we want to do AI engineering activities, whether it is feature engineering, whether it's model training, or whether model scoring, or even visualization. All these are done on top of the Snowflake Data Cloud. The Snowpark engine is basically used for feature engineering purposes and model training purposes. And then we have built a number of Streamlit apps as part of Refract Marketplace, which can be further leveraged by end users and data scientists and validators to accelerate the work they do with respect to AI ML engineering on top of Snowflake. And I'll give you a glimpse of some of these when I do the demo. So finally, if you look at what is the value proposition when you take Refract and Snowflake together, so some of the things that you can look at is there is a lot of out-of-the-box support for Snowpark. These may be anything from pre-built templates, code snippets, integration already done with, say, a feature store like Feast. We also provide a lot of quality checks for the Snowpark code, whether it may be static code analysis, whether it may be code testing for the Snowpark code. And also we provide a lot of out-of-the-box Streamlit tabs, which simplify the job of many of the personas who are involved in ML engineering activities. With this, let's get into the Refract demo. So this is the opening screen. Generally, there are multiple role-based access control personas that can use Refract. This is sort of the typical say sort of login used by a data scientist persona. Everything that you do in Refract is basically under what is known as a project. A project encapsulate all the work that you do with respect to your data sets or model development, storing your configurations, storing your infrastructure related settings. So all these things are encapsulated under a single term called project in Refract. So basically you build projects, and these projects are basically mapped to use cases. So if you want to do a warranty analytics or price analytics, demand forecasting, so basically you will create a project in Refract for that. So whenever you create a new project, Refract tries to support good ML engineering practices. For example, you will not be able to create a project without having a version control repository. So you can either select any of the version control repositories like a Bitbucket or a GitHub or a GitLab, or you can go with a default one, which is GitHub. So everything and all the artifacts that you create as part of the project are automatically say version control inside the Refract repository. Now for today's demo, what I have done is I have already created an existing application, which is existing project, which is loan defaulter prediction. So we will use this say project to understand how Refract and Snowflake work together to solve ML problems. Now, we'll start with the data scientist persona. And typically, when you look at a data scientist, he first investigates the data. Understanding data is something that is very natural to a data scientist, because if you want to do feature engineering or if you want to do hyperparameter tuning, all these activities basically requires a good understanding of data itself. So in Refract, you can actually get data from an external file. However, this is just for a quick POC or an MVP. This is not the ideal scenario, but in most cases, you will actually use a catalog from which you can say sort of import data sets on which you want to do your AIML say sort of training. So here you can see multiple assets that you have. So now the first activity the data scientist would do is to basically import data sets from a particular data repository. So as you can see here, Refract provides a number of say sources from which you can actually import your data set. One of the most popular ones is definitely Snowflake. So whenever we want to import data from Snowflake, you just say sort of click on the Snowflake icon, and then you can actually create a connection between Refract and Snowflake in a very simple way so that you can import the data. So currently I've already created a couple of connections so that we can progress quickly with the demo. And then from that connection, we have imported multiple data sets. So let me take a very simple data set and see how Refract helps to analyze the data which is there on Snowflake. So if you look at this, we have this customer loan details data set or a table. And then you can see high level information regarding like what is the source type and where exactly the data is coming from, how many records are there, etc., etc. So all this information is already available. You can also define some business terms with respect to the data if you want. Also, Refract automatically fetches the technical metadata, and you can look at what are the different column names. And for example, this is loan ID, and then this is interest rate, and then it also shows you some sample for that data. The PII columns are automatically hidden once you tag them as PII, so that data security is respected. You can also have a quick say profile of the data that you have, and it works with various types of data. It understands the type of the data, and then accordingly either it draws a histogram like interest rate. You can see it is in a histogram, or if it is a text data, then you have a word cloud. So it is intelligent enough to understand, and then it will give you a quick profile of the data. You can also look at more complex things, advanced things like the accuracy of the data set, the completeness of the data set, uniqueness. This will generally give a data scientist very high degree of confidence on whether to use this data set for model training activities. And there are a lot of additional capabilities around this which can be used by data scientists, but at least at a primary level, data scientists typically look at the technical definition of the data. They also profile the data and also look at the data quality dashboards for a particular data set before they actually start building the model. Now, once you have looked at the data and you have understood the data, and then the second step in this process is basically to go ahead and build models using the data that you profiled and had a look at. So in Refract, basically, we provide notebooks, and these notebooks are very tightly integrated with the Snowflake Data Cloud, and they provide a lot of capabilities out of the box, which accelerate the development of use cases on top of Snowflake. For example, whenever you want to set up a Snowflake specific project with respect to Refract, you already have a lot of templates. Refract can run in dual mode. Whichever models are supported in Snowflake to be run through the Anaconda repository, for example, those can be run completely in Snowflake. Both from a training and a scoring point of view. However, if there are models which require certain libraries which are not currently supported, then you can run it using a Kubernetes kind of an infrastructure outside Snowflake, where data is still in Snowflake and can be fetched from there. Now, for example, here I have created one base template. And if you look at this base template, it's basically a Jupyter notebook, and this Jupyter notebook is configured to run on Snowflake, and anybody who is in the organization can, with access rights, can use this base template. And here we have already defined certain infrastructure, certain environment variables, whatever dependencies that we require for the latest version of Snowpark from a Python point of view. You can also define some additional settings. So basically, this base template provides a quick start, an opportunity for everybody in the enterprise to start using data from the Snowflake for building ML models in an accelerated way, because all the settings and configurations, etc., are already done in this template. Now, once you do that, what we have gone ahead and what we have done is we have taken this to the next level, where we have created a number of code snippets which are already available for somebody who wants to work quickly on Snowflake with Refract. So I'll just open one specific example. So now we are looking at loan delinquency use case, and this is a Jupyter notebook which has been developed to train the model and register the model in Snowflake. Entire thing is happening inside Snowflake using say Snowflake stored Python stored procedure. Now, if you see, the interesting part here is we have number of snippets here, and assume that there is a new data scientist and he wants to work on Snowflake and he's new to Snowflake, or even an experienced developer wants to quickly build some models on Snowflake. So here, for example, if you want to import all the Snowflake helper libraries, you can just click on the snippet and you have all the helper libraries which get implemented. So you just have to change the file name in this parser.read to the configuration file, and then it would automatically connect. You have other areas like you can have connection parameters, and then you can have things like session creation. So pretty much whatever the steps that generally someone takes in order to develop a ML model in Snowflake is all captured in terms of snippets, and all these things are are used to accelerate and make sure that mistakes don't happen when you are building your Snowpark models within Snowflake, right? So now if I go back to my original loan delinquency notebook, so this contains the end-to-end process of building an ML model, and this is built on top of the template that we saw earlier and using the code snippets that I just demoed. So we imported all the libraries which are required, including the Snowflake connection. Then we are using the feast feature store, which is getting data from Snowflake. So the feast feature store is something which supplies the features to the training thing. We can verify the entities in terms of what are those entities, and we can look at what exactly the primary keys and multiple views, and we can also look at some sample data from the table from which we are going to train the model. And then further, once we have done the feature store configuration and we get the historical features, all the feature store related thing, then the real hard work of creating the ML model begins here. So we have the Snowpark Python stored procedure, which is getting created here. And this contains multiple type of the models that can be used to compare the accuracy metrics. For example, here we are training the models, and there are three classifiers: random forest, and we have a decision tree, and then a gradient boost. So these multiple models are say sort of run, and the metrics are captured and compared. And in order to train the model, we are calling the stored procedure, the procedure that was created here, and it actually runs these three models that we talked about, and then it picks up the best model that should be registered. So once you call the stored procedure, basically builds a model and creates a pickle file, and then that is put into a staging area so that we can use that pickle file for the next set of activities. So finally, the model is created, and then it gets registered through Refract, and therefore we went from data analysis to a feature store to building a stored procedure which actually trains multiple models and selects the best model, and finally we have now registered the model, all in the course of say few minutes or an hour or two, because most of the infrastructure that is required to do this is already available through Refract, and a lot of code snippets and other surrounding pieces already made available. Now, once you have built the model, the next step actually is to make sure that this model is say valid, and therefore for that purposes we have to go to the model validator persona. So the data scientist already conducted the experiment in Jupyter. He is happy with the model. Now he has registered that model. So therefore the next step is basically to make sure that this model is validated by the model validator or model quality assurance, so that this model can be deployed into production. So in Refract, for the model validator persona, we have something called as a workflow. This is for model validation. And typically the model validation, there can be more things added, but typically they look at whenever you supply a model, they will look at data quality of the model. then basically the quality of the data that is fed into the model accuracy, and the explainability of the model. So in Refract, it is very easy to configure these things. For example, if I want to configure the data quality, so now the validator has his own validation set. So he can set up that particular validation set here, and then basically he can say run. So now what happens is there is a job which gets scheduled, and then it applies certain tests on the validation set to capture the say sort of findings. So if I just open that and look at the output data, so you can see that there is an app that gets visualization that gets generated, and here it captures a lot of metrics related to um, the validation set that validator is using before he starts validating the model itself, right? So you can actually expand this into a bigger screen, and you can look at individual variables. You can also look at things like correlations across two different set of variables. For example, here you can look at Spearman correlation or Pearson correlation. So you can look at definitions of those correlations. So there are a number of things that you can do, starting from individual variables to correlations to missing values to sample data, looking at duplicate rows. So all these capabilities are provided so that the model validator can first have a 360-degree understanding of the data, with which he's basically trying to validate the models, right? So once you have validated the quality of the data, then the next step is to actually look at model accuracy. Again, you can configure the model. So here we have the .gz file, which is available in the Snowflake stage, and then you can provide the data set against which you want to run the say model analysis. Again, you can configure this and click run button, and then we will have the run of that, which will basically run the whole thing. And then once you have that, again, you can look at the metrics here. Since it takes time, I have already kept it open. So you will get an app, something like this, where you are looking at various aspects related to model quality. So you can look at model testing, and then, for example, what passed, what failed. For example, AUC score for all the classes should be greater than 0.7, but that is not the case. So this test case has failed. So there are an elaborate set of test cases which have been defined, pre-built, available, which can be used for model testing. Data is also part of the overall validation. So data, the code, all these things can be say sort of tested by the model validator. And finally, the explainability is the last part, and this is very important, because if there is a black box model which cannot be sort of understood by end users, it becomes difficult to productionize it. So here again, we provide the model and then provide the data so that you can check the explainability of it. And again, you can run this, and it basically runs, it gets scheduled, and then it runs, and then it again provides a report similar to say this. And then here, this is the explainable AI report that gets generated, and you can look at things like, for example, feature importance. So you can look at interest rate and loan to value and debt to income ratio, etc., are most important in understanding, predicting delinquency. You can also look at basic model stats like accuracy, recall, ROC, AOC score, confusion metrics, etc. You can also look at say local expectation for individual records. For example, you can select something like an interest rate, and you can see that there's a as the interest rate increases, there is a higher chance of delinquency. So there are a number of say sort of metrics which are available for the model validator to look at and say whether this model is something that should be deployed into production, right? So you looked at data, we looked at model, and then we looked at explainability of the model. So therefore, the model validator hands off this basically to the final step, which is deploying the model, right? So once the validation is done, you come to the say the model section, which is for the MLOps persona, and then basically you can take that particular model and then you can deploy that into production. So currently whatever model that we built, so this is not yet deployed. There are some models which are already deployed, so therefore you can just click on this option, deploy, and then there are multiple strategies for deployment. You can do A/B testing or canary, or you can do a ramped up. So there are various variations, and you can also select the infrastructure that you would like for that, and then you can apply that particular deployment strategy, and this would deploy the validated model in production. So while this is being done, the MLOps persona can also look at build time metrics. He can basically look at all the accuracy metrics and the F1 scores, etc. And he can look at the overall feature importance, decision tree, all this type of stuff. He can also look at basically things like invocation metrics, and currently invocation metrics would not be there because we just deploy the model, so this will be empty. But once this model, currently it is in deploying state, and then once it gets deployed and then people start using it, you will get a set of invocation metrics in terms of how many API calls were done, what is its latency, and then say how many API calls were successful. So now we basically deployed this model. The last part for an MLOps person is he would like to monitor this model for various issues and anomalies, so that he can take corrective action, like for example retraining or stopping a model if the accuracy is really bad. So this is typically done using a pipeline very specific to the MLOps persona. So for example, we have here feature drift, we have prediction drift, we have label drift, and say model drift. And then there are a set of conditions that you can do, like for example, you can trigger the retraining pipeline. So again, for example, if you take feature drift, you configure this in terms of the current data that you are getting and the past data that you are getting. Of course, all this data is already in Snowflake, so it makes it very easy. And then once you run that, you get a set of output which you can use to understand how exactly the say the feature drift works, right? So similarly, there is label drift and prediction drift, and what we have done is we basically have built a app, say Streamlit app, which can do all this functionality out of the box. You can look at model drift, feature drift, prediction drift, label drift, and this is very comprehensive. And in future, we will be able to host it natively on Snowflake. So you can look at each individual portions of this using this Streamlit application and understand for that particular model. The MLOps engineer can understand what exactly is happening. For example, here drift is detected 6 out of 14, and you can go down and you can actually see which are the areas where drift is detected and which of the areas the drift is not detected. Say for example, here you see a drift in terms of the distribution, right, in terms of the features. Similarly, you can look at the prediction drift, and it will give you a lot of say sort of insights into how the drift is occurring. And we can look at a lot of matrices, and we can drill down to the next level to look at the individual distribution between the previous and the current data set that we have. So so with this, the MLOps engineer will be able to take corrective action, and then he can actually guide the data scientist team to say sort of fix any issues that he sees. So with that, I'll come back to the say sort of original value proposition. So Refract enables you to build end-to-end ML engineering projects, use cases on top of Snowflake. We have built a lot of capabilities natively on Snowflake to accelerate and improve the productivity of building AML projects. So I think you got a good overview of what are the core capabilities, and then there are a lot of other capabilities which we can say sort of dive deeper into. With this, thanks everybody. I hope this session was useful for you.